Is it audible now? Am I audible? Support. Click on more structure for the support. This is the short key for support. Click on create. Just click the fixed support. Click on add. Click the fixed support. Make sure all the nodes are selected where you want to give the support. For that, click on isometric view. Click on assigning to the selected node. Now here click on assigning. Then permit for the procedure. Click on yes. So you can see. Now we'll give the member property again. For that, go on command member property. Click on save matrix, or else the shortcut is you can click page property. Click on define. on the rectangular. Make sure the material is concrete only. For beam, use the dimension 0.323 into 0.23. Click on add. For column, give the dimension 0.3 into 0.30. Click on add. Now for the flat thickness, click on thickness. Here also make sure the material is concrete. Do the flat thickness 150 mm. Now select the parallel to y-axis. Use the property for the column. Select the column. Parallel to y-axis. Select assign to selected beam. Click on assign on this. So you can see. समझता था जिथे समजत नाही तिथे सांगा Now similarly give the property for the beam. Click on property. Select the beam. For selecting the beam, click on beam parallel to x-axis, beam parallel to z-axis. Now assign the properties assigned to the selected beam. Click on assign. Click on yes. Here you can see. Here it highlights. जेव्हा आपण इथे रेक्टँग्युलर 0.23 कॉलम ज्या प्रॉपर्टीज आपण कॉलमला दिल्यात त्या प्रॉपर्टीवरती क्लिक केलं की इथे हायलाइट होतं. ओके प्रॉपर्टीज झाल्या. For loading, go to command, then in command click on loading, go to primary loading, click on primary loading, or else you can go to the property, go for the loading page. Here directly you can click on here, the loading page will be add load and live load only. Give the title to the load, dead load, then live load, dead load. Click on add, click on self-read, it's in y direction and it's downward y direction, that's why here minus sign is there. Click on add. Now here you can see the question mark. That means we haven't assigned the load yet. Okay, so for assigning, click on the self-read, assign to view. Now click on live load. Click on add. Now click for the live load. Now you need to click on floor load. Okay, floor load. Pressure for the floor load for the residential building we consider as 3. Now it's in downward direction, that's why we are giving it minus sign. Now give the rate. So here you can see the minimum one. They're asking for the minimum to maximum days. Minimum is 1, maximum is and you can see the loading. समजतंय सगळ्यांना? प्लीज रिस्पॉन्ड. समजतंय? Okay. Now give. आता आपण walls loading here. Okay. Slab load. Wall load, slab load is also considered as a dead load only. Okay, so then second is slab load and slab pressure. So click on dead load again. So click on dead load, then click on add, then click on floor load. Okay, for the slab load is -4. If I assume it's -4.7. Okay, now give the pressure range. आता आपण किती दिली 1 to 6. Okay, now click on add load. Okay, हे आहे आला आपला slab load. Okay, you can see the loading. Just if you click here, it will highlight on the structure. Okay, now wall load is also a dead load, so one more load will add in the dead load. So click on dead load. Now click on add button. Now click on member load, because wall load is considered as a UDL. So now it's -13 if we consider width of a wall. So how we can calculate the member load? Width of a wall into height of a wall into project of depth plus 1. 1 plus 1 we consider for the plastering, or for that we consider plus 1. So 0.3. So 0.23 into height is 3 meter into density of brick, if we consider it 20, plus 1 for the plastering, it's 14.8. So 14.8. Okay. तो हा कुठे जायचा होता? अजून आपण असाइन केलेलं नाहीये, दॅट्स वाय क्वेश्चन मार्क इज देयर. सो हा लोड असणार या दोन ह्याच्यावर. click on top view. Now select the beam where this load will come. Now assign. Now click on assign to selected beam. Okay. Here you can see. आता हे एका फ्लोर साठी झालं. Now similarly, this floor. Select the area where you want to assign the load. Go to the view. Now select view. Select view selected objects only. So now this is for the outer wall. For the inner walls, the thickness is less. So it's 100 mm. So 0.1 into height is 3 into density is 20. Density of brick is 6 plus 1 for the plastering. So it's 7. Now again go to bed load. Click on add. Then member load. Then minus because it's downward. 7. Now select where we want to give this load. So click on assign to the selected beam. Click on assign. Now part is done. Now these are the loads. For the load combination, go to the command, then loading, then go to the load combination in loading. Load combination. Now click on command, loading, load combination. Now transfer the available load cases to the selected load cases. Okay, so transfer the available load cases to the selected load cases. Okay. Now define factor of safety 1.5 dead load as well as light load. Right. Now click on add. Here you can see the load combination. Okay. Now check for member property. Go analysis. Go to select. Here go to the missing attributes. No entry in the missing property is found. Now we can go to analysis. Now go to the analysis. Run analysis. It says 0 error. Now go to the support analysis. Click on no break. Click on OK. Now toolbar. Run analysis. Now 0 error. Now save. Now click on go to post processing. processing mode. Done. Click on apply. Okay. Okay. Have you understood? I hope you have understood. Okay. Now in post-processing mode, first we'll see the beam forces. I'll give a note for the beam forces. The beam forces are to be observed in the local axis of the coordinating members. To easily understand the local axis, use the right hand thumb rule in which uh, your local x direction is shown by your index finger, local y direction shown by the thumb, and local z shown by the second finger. Okay. Okay. Uh, Post processing. The effects. Here effects denote the axial force in beam. Effects in beam. Effects denotes the axial force. Fy denotes the shear or transverse force. Fz denotes the lateral shear force. Mx denotes the movement above. Very. Mx denotes the movement about x-axis. X-axis. Okay. Mx denotes the movement about x-axis or torsional movement, we can say. And my denotes the movement about local axis y or lateral bending movement, and mz denotes the movement about local axis z or the bending movement. Okay. Now, okay. Now you can see the screen. Okay. I hope now it's visible. Still it's not visible.
Now it is visible.
Okay. Okay. Here. Okay. I'll show you one thing. No problem. In the post processing, select the beam. Okay. In beam, here the x direction, here fx, fy, fz, mx, my, mz. What it denotes? Fx denotes the axial force. Okay. First, I'll tell you the beam forces are to be observed in the local axis of the coordinating members. Okay, to easily understand the local axis, we use the right hand thumb rule. in which your local x direction is shown by your index finger, local y direction shown by the thumb, and the local z direction shown by the second finger. Okay, here fx denotes the axial force, Fy denotes the shear or the transverse force, Fz denotes the lateral shear force, Mx denotes the movement about x-axis or torsional movement, My denotes the movement about the local axis or the lateral bending movement. Okay, and Mz denotes the movement about local axis Z, that is bending movement. Okay, if you want to take a note of that, you can. I'll repeat again. Fx is the axial force, Fy is the shear or transverse force, Fz is the lateral shear force, Mx is the movement about x-axis, that is torsional movement, Fx is the torsional movement, My is the lateral movement, My is the lateral movement, and Mz is the bending movement. Okay. समझता right click, go to label, click on beam orientation, apply. The effect Fy Fz orientation. I hope you have understood. इन्स्टॉलिंगचा व्हिडिओ मी तुमच्या ग्रुपवरती पाठवलाय, बघितलाय का कोणी? इन्स्टॉल कसं करायचं स्टार्ट प्रो? काही प्रॉब्लेम असेल तर सांगा त्याबद्दल. आपण आणि एकदा बघूयात आपण स्टार्टिंग पासून की आरसीसी बिल्डिंग आपण कशी डिझाईन केली. ओके, we'll take a new project, click on new project, click on space, give the file name, suppose RCC. Unit should be in meter and in kilonewton. Click on next, click on add. Okay, no sound. Okay, no problem. hold on. Okay, click on new project. Okay, now click on space because we are creating a 3D structure. So click on space. Now give the file name. Suppose RCC. I gave my file name RCC. Give the location to that file. Okay, I gave the location at the desktop for the file. Okay, units should be in meter and in kilonewton only. Okay, now click on next. Now click on add beam and now click on finish. Okay, now this interface will come. Now click on edit in the snap node or beam. In the snap node or beam, click on edit button. Okay, now click on XZ plane. Okay, click on XZ plane. Okay, now click on OK. Okay, now click on snap node beam. Now give a reference point. Okay, now just escape that. Okay, now click on transitional repeat command. Okay, now click on transitional repeat command. Now go to the geometry, click on transitional repeat, or you just can simply click on here transitional repeat. Okay, we take a simple, we take 3 columns in x direction of 5-meter spacing. Now click on link step. Now click on OK. Go to transitional repeat. Click on 5-meter. Click on link step. Click on OK. Okay. There you can see. Okay. Now again. Go to the top view. Now click on. Now select this all. Again go to the transitional repeat. Click on Z axis. Give the minus sign. Click on 3. Spacing is 5 only. Give the 3 steps. Click on link steps. Click on OK. Now you can see the structure. Okay. Now you don't want this mesh. If you don't want this mesh, you just can simply cancel it. Okay. This is the structure. Okay. Now this is the model. Here the modeling part is finished. Now we want to do the framing. For that we need to give the height for the structure. This is the isometric view. This is the line, this is the plan. Okay. Now for that select all the beams. Again go to the transitional repeat. Go to the y direction. Give the number of steps maybe 3. Okay, 3, and default step spacing, if we give the height of each story is 3. Now give the spacing height is 1. Okay, now click on link step, click on OK. Now we don't want this part, the highlighted part we don't want, because the foundation मध्ये जाणार. ओके, फाउंडेशनला डिलीट करून टाकू. ओके, स्ट्रक्चर झालं आपलं. ओके, यू कॅन सी दॅट इन द rendered view as well. Okay, now again, now give the support to the column. Okay, now for that go to the command. Okay, go to the command, go to the support specifications, go to the fixed support. We want to give the fixed support, right? Go to the fixed support. Here click, here so many supports are there: pin, fixed, but enforced, वगैरह. So but we want to give fixed support, right? So click on fixed support only, click on add. Now click on fixed support. Okay, now go to the front view, select the nodes. Okay, select the nodes. Just make sure all the nodes get selected. Okay, here you can see nodes are selected. So click on assign to selected nodes and assign. Okay, you can see here it's assigned. Okay, now give the member property. For that, again go to command, select the member property, go to the prismatic, select the rectangle, give the dimensions of beam, click on add. Now give the dimensions for column and material is concrete. Now click on add and close. Okay, and for the slab thickness, give 150 mm. Click on add. Now we haven't give the plate. Select the first, select this part, go to the isometric view, click on add 4 noded plates, give the plate. Okay, and just use the transitional repeat command and transitional repeat. Select the plate cursor, select the plate in bi-direction. Height is 3 meters. Number of steps is 2. Height is 3 meters. For the 0.23 into 0.223 is the size of beam. So for the beam, go to select to beam parallel to x-axis. Select again, go to select beams parallel to z-axis and click on assign to selected beam. Assign. Now we want to give the property to the column. Now select, click on beams parallel to y-axis. Click on assign to selected beam. Click on assign and now plate thickness. Now this, for the plate thickness, click on assign to view. Okay. Now you can see the member property we have. Now the next part is for the loading. Now again go to the command, click on loading, select the primary loading, click on dead load, click on give the name to the load, dead load, click on add again loading type. The second loading type is live load. Give the name to it, mouse load. Click on add, close. Now again click on dead load, add dead load. What are the loads come in dead load? Very first is self weight. Okay, so for that go to the self weight, click on y-axis, factor is 1 and minus sign because it's in downward direction. Click on add. Okay, self weight. Now then here you can see the question mark which shows us that the load is not yet assigned. Okay, so again click on self weight, click on assign to view, click on assign, and yes, self weight is given to the structure. Okay, now the second dead load is slab load, but we have provided plates here. So earlier what we have done, we haven't provided the plate and we gave the slab load, but now in this project we provided the plate. Okay, you can see it in a rendered view. Okay, we have provided the slab. Okay, so slab load separately we don't need to give, considered in a self weight only. Okay, then wall load. Now so again go to dead load, click on add. Now go to the member load. Now calculate the member load. How to calculate? Width of wall 0.23 into height of wall is 3 into density of bricks we consider as 20. So 0.23 into 3 into 20, it's 13.8 plus 1 for the plastering. Now give it a minus sign because it's in downward direction. 14.8. Now add. Okay. Now the outer wall is the thickness of the outer wall is 0.3. And thickness of the inner wall is suppose 150 mm. So for that also we will consider 0.15 into 3 into 20 plus 1, that is 10. So again go to belt load, click on add, go to member load, minus 10 kilonewton per meter in y direction, in downward direction, downward y direction. Click on add and close. Okay, now we have to assign. Okay, now stepwise we will assign this load. Go to the front view, select the ground floor, go to the view, click on view selected, objects only. Now the minus 14.8 is for the outer side and minus 10 kilonewton per meter is for the inner wall. Okay, so select the outer wall, select the outer wall area, and the outer wall area. Selected view. Okay. Out. Select the inner wall. Select the inner wall. For inner wall, we give the 10 kilonewton in the downward direction. Let's click on assign to the selected beam and assign. Okay. Here, if we click on 14 kilonewton, 14.8 kilonewton, we click on 14.8 kilonewton, it will show in blue color. The selected load will show in blue color. Okay. Now we have to give for the second floor as well. Now again go to the next floor. You select the view selected objects only. Now use the isometric view. Again 14 kilonewton is for the outer wall. Select so 14 kilonewton is for the outer wall. So select the outer wall only. Now click on assign to the selected beam. Now click on assign. Okay. Now similarly for the inner walls also, select the inner wall plane. Okay. Click on assign to the selected beam. And now see the whole structure. Okay. Now we'll add a parapet wall also. Now for the parapet wall, for the parapet wall, add, go to dead load, click on add, then click on member load. If the parapet wall, the loading, if you suppose it's 5 kilonewton per meter in downward direction, that's why it's minus. Right? Click on add, close. Okay. Now parapet wall is just for the outer periphery of the structure. So just select the top floor, click on view selected objects only, go to the isometric view, select the outer walls only, select the outer walls only, and give the loading. Click on assign to the selected beam, click on assign, give the whole load. Okay. Give the self weight, give the outer wall loading, inner wall loading, parapet wall loading, and now right. Right. Okay. Right. So go to the lowercase detail. Okay. Lowercase detail. Click on add. Click on live load. Now live load. Click on add. Now define the floor load. Okay. Now define the floor load. Live load for the residential building in the IS code given is 3 kilonewton. So give the load 3 kilonewton. Okay. So there are two methods. We can give the range also, or we can assign by using cursor. But if we give the range, it's simple method, but sometimes it goes wrong. So we'll go by using cursor only. Okay. Click on add, click on close. Load, add, go to load load, minus kilometer, control G, create a group here. Okay. Floor, floor 1, click on floor, click on OK. V group. Floor 2 on floor. Okay. Floor 3. Floor 3 on floor and okay. Now assign like for the floor 1. So again, then selected view only, go to the for the select the first floor, associate. Now select the second floor. Select the second floor. You can see it gets selected or not in the isometric view. It's selected. Click on associate and third, select the third. Check in the isometric view that it gets selected or not. Associate and click on associate to selected geometry and click on associate. Okay. Okay. Now here click on group. Now for the first 2 floors, the live load is -3. So click on floor R1, floor 1 and add. And for the second floor also, the live load is -3 and click on add. But for the last floor, live load will consider as -2. Okay. See here the live load. You can see the load. Now loading is done. Now what we need to do is next step is load combination. Again, go to command, then go to loading, then go to the load combination. Okay. After now what we need to do now load, go to command, loading, load combination. Now transfer the available load cases to the selected load cases. Okay. Now give the factor of safety 1.5. Load as well as load. For member property before analysis. प्रॉपर्टी दिली आम्ही कसं चेक करायचं हो analysis in command. Go to the command, go to analysis. Yes. Go to the select, then click on missing attribute. Click on, go to select, go to missing attribute, go to missing property. And they're saying that no entry with the missing property is found. Okay. Now just for the sake, once again check the duplicate nodes and members. Check duplicate for the node. So we are done with the load combination. Now go to the command analysis, perform analysis, click on no print, click on OK. Now go to the analysis and run analysis. Okay. Errors are 0, warning is 0. Okay. So go to post processing mode. Okay. Click on apply, click on OK. Okay. Now go to the beam. They are showing the that you can see the bending movement diagram. Okay. So you can see the bending. If you want to see for a particular member, just select that. Shear force diagram. Deflection is showing. Loading. Just double click on the member which you want to analyze. Okay. They're showing loading, shear force, shear bending, and deflection. Okay. Go to beam. You can see fx, fy, fz, mx, my, mz. Okay. Okay. So they are showing. So they are showing the okay. The beam forces are to be observed in the local axis of the corresponding member. Okay. आपण बघितलं की startingला I have stated the difference between the global axis and local axis. Local axis is for the member itself and the global axis for the whole structure. Okay. And to easily understand the local axis, what we do, we use the right hand thumb rule in which your local x direction is shown by using index finger and local y direction shown shown by thumb and local z direction shown by the second finger. Okay. You can see the x, y, z direction. local XYZ direction for the particular beam. Okay. Now movement, now effect. So now what this effect denotes? Here you can effect. Now the effect denotes the axial force. Fy denotes the shear force. Fy denotes the shear force. Fz denotes the lateral shear force. Mx denotes the movement about x direction or the torsional movement. My denotes the movement about local axis y or lateral bending moment, and bending moment is denoted by mz, that is movement about the local z axis. Okay. Now then go to the modeling page, run analysis, go to the post, go view the output file, and this is the file. So we can see the design. So we are done with the modeling part, framing part, loading part, analysis part, and design part as well. Okay. I hope now you have understood for what I have said. Now practice this. And I will provide the PDF to you. So session is over today. Tomorrow the class is at 1 p.m. Please attend the class, and before leaving, please give the attendance. Please give the attendance. Please give the attendance in the chat box. सेशन कळालं तुम्हाला? Please unmute yourself and talk about the session. Have you understood what we have done till now? Please speak up, otherwise your attendance will not consider. Have you understood? You're done with the attendance? Shall I close the meeting?